once we get through a couple of weeks, it'll become clearer.
Okay.
So welcome back, everybody. So this thing is due January 28th now. I thought I could sort of jump in and short circuit a bunch of stuff, and it's turning out that I can't. So that's fine. We're not in any way behind. It was mostly me trying to get ahead. So what I thought I would do is start out with a demo of my list.h or my list program so that everybody kind of has an idea of what we're getting at. And then my plan is to go through and review command line arguments, opening external files and reading data from them. We are going to talk about sorting a linked list, which I don't think is in either of the readings so far, and it's definitely going to get your mind thinking about linked lists. And then I'll finish with that repetitive prompt that I asked you to implement, where it's going to keep asking for numbers until you don't enter anything. Some of you that have had me for C++ may have seen that before, but others maybe not, so it's definitely worth talking about. So any questions before I get rolling? All right, well, let me get myself a window onto Caret. All right. I think everything's up to date on this thing. So if you look at my makefile, I tweaked my makefile so that the name of the binary is called stats, and you can do that with the -o command, -output, -o. So instead of the default binary name a.out, I can give it any binary name that I want, and I'm going to call it stats. If you look at nums.dat, it's got a bunch of integers in it right now. These are integers that this is a set of numbers that I got off of the web when I was testing my standard deviation program. I wanted to make sure that the calculation was actually doing what it was supposed to do, because unlike mean and median, where you can just look at a set of numbers and have a pretty good idea whether it's right, I can't just look at a set of numbers and say, oh yeah, the standard deviation is absolutely that. I'm not that good a statistician. So I went out and found a discussion. First of all, I went out on the web and found a formula for standard deviation, because don't have that memorized either. And along with that formula, the particular page that I was looking at had an example with these numbers. So I just copied these numbers into this data file, ran it, and when my standard deviation matched up with their standard deviation, I was satisfied. So let me show you. So these are the numbers. I'll run stats, and then the argument to this program is nums.dat, the file name that has the data in it. I run this thing, and it starts off with a list of the numbers, and they're sorted, and then the summary statistics, they're 20 points, the mean is 7, the median is 7, and the standard deviation is 2.98, yada, yada, yada. And now I'm dropped into this repetitive prompt asking me for additional numbers. So let me throw a 2 on the pile. So I throw a 2 on the pile. You see there's an additional 2 now. The number of points is incremented by 1. The mean is tweaked. The median is the same, just because that's how it worked out. And the standard deviation changed a little bit. I could throw another 2 on there, and now the median starts to drop a little bit. And when I've decided that I've done enough, I can just hit enter, and it exits. How many of you guys have seen this before from me in C++? Any of you? Some of you? Okay. So I'd like to talk a little bit about, let's see, is that what I want to start off with? Let me first start off with getting a file name from the command line and using it to open a file. So, let's go here, I guess.
Quick question.
Yeah.
I think you might have mentioned this. Is there any way to open another command line from within PuTTY?
Absolutely. So just hit it again.
Okay, so hitting it again.
Yeah.
So you have to log in again and everything, and logging in twice isn't gonna make this guy all that.
Right. Yeah.
Okay, thanks.
There's a thing called screen, which I fear to show you. So now I'm in screen, and if I want, so I can change into, say, 270, and then I can make another window, Control A, Control C, and now there's a window there, and I hit Control A, Control A, and now I'm back there. And I can have as many of these windows open as I want. And then I can even detach from it, Control A, Control D, and exit, and then I can come back and reattach. I love Screen. I think it's just an awesome program. And there's my terminals back again. So there's one gone, there's another one gone. Now I'm out of Screen. Now I'm out of the terminal. So if you want to learn how to use Screen, which, like I said, it's a pretty awesome tool to know, because you can launch all these virtual terminals within an existing terminal and switch between them and copy and paste between them. My favorite thing is you can start a program. You can start a program running on the host machine, and then you can detach and literally log out and walk away. And as long as that machine doesn't shut down for some other reason, you can come back, reattach, and there's all your running programs and your whole terminal and stuff like that. It's really cool.
Is that why they tell you not to turn off computers in that class?
It's one of the reasons, but not really. I don't think they're. I think you guys in this room, me and David Gashard, are the only people in Walla Walla, Washington that know about Screen. Maybe not in Walla Walla, but certainly at Whitman College. Okay. Where was I? So we want to talk about getting information off of the command line. I'm debating whether I just want to show you code. Nah, I think I'll write it. And let's open this and browse to this. I'm going to open an older one. There's me playing with linked lists. Okay. So a lot of your programs start like this: int main, and then there's some stuff in between. And we rarely talk about what goes on in here. So in between the parentheses, you're allowed to put arguments to the main function. And really, there are only two arguments that main understands and recognizes. There's argc, which is the argument count. And then there is a pointer to the argument array, argv. And this is the list of command line arguments. And these are delivered from the shell. All right. So if you want to use these guys, then your int main should look like this. Your int main declaration. All right. Now what happens when I throw this in there? Let me go back here and go up arrow. What happens is the first guy here, the /stats, is a string that will be the first element of the argv array. So the shell, that's what this window is. It's called a shell. When it runs the stats program, it passes these two arguments, the stats and then the nums.dat, into the main program, into the argv array. So when I'm inside the program, if I look at argv0, it's the string ./stats. And if I look at argv1, it's nums.dat. So the shell will take the command line and chop it up at space characters and stick each string between spaces, stick each string into this argv array. And then argc in this case would be 1, which is, sorry, argc here I think is 2. I think argc is 2 here. 0 has stats in it and 1 has nums.dat. How many arguments are there on the command line? There are 2. So argc is 2. All right. How is this useful? Well, if you're trying to feed information to the computer from the command line, you need to use the argument array. For example, here's a program, ls, right? It lists the contents of the directory that you're in, and ls is just a program, just like stats, and I can feed options to it. For example, I can get a long listing of what's in this directory by including -l, and then I get more information about what's in the directory. Well, how did ls know to change its behavior? Well, if I could look at the source code for the ls function, I would see an argc and an argv, and the argument array is going to have this -l sitting in it. And inside the source code for ls, the writer of the ls program spends a massive amount of time trying to parse the command line, figure out what kind of options the user is trying to send to ls. If you look at the manual page for the ls command, you'll see dozens of options. So I would wager that 90% of the ls command is parsing, of the ls function is parsing the command line. Just going through and figuring out -l, -a, -r, -t, -k, what to do, how to change the behavior based on all of that information. Parsing command lines is pretty involved.
Is there a difference from a command line's point of the shell's point of view, whether it has a dash, an argument has a dash before it, or it's just something that's basic?
It depends on who wrote the ls command. So ls wants dashes here, or you can have the long version, like you can use -i or you can use --inode, and it'll recognize both of those. But it's entirely up to the person that wrote the function, what kinds of arguments you can send to it and what that syntax has to be. So this is a really common thing to use in command line programs like we're writing this week. That's how you pass stuff in. I guess I will go in and look at my main program here. So here's my main program. And you see there main argc and then the argument array. Files. Let's talk a little bit about files. So if you want to read or write from a file in a C++ program, you have to include the fstream header. File stream. That's what F stands for, file stream. File stream gives you two new classes. It gives you an if stream type and an OF stream type, off stream type. An if stream is an input file stream. That's what we have to use because we're trying to get data from a file into the program. If I, on the other hand, were writing data out to a file, then I would have to also get my hands on an off stream or an OF stream object, which is an output file stream. The syntax is really similar. It's summarized in the book here. You can look at that. For our purposes here, I have an if stream object that I'm going to call capital DATA, data. I often call my file stream variables, I often use all caps for file stream variables. It's not something that you have to do, it's just something that I tend to do so that I see, yeah, that's a file handle variable. In the parentheses, there's a, I can feed it argv1. And what's sitting in argv1? nums.dat in my case, right? It's the string that has the name of the file that you want to open. I feed that to data as data has a one argument constructor that'll take a string and it'll just go out there and open that file. I'm not being really careful here. For example, I'm not checking to see if the file actually exists or whether this file opening was successful. A good programmer would do that, especially in a production piece of code. This is largely code that we're writing and using ourselves, so we're not as concerned about that. Okay, let's talk about how to read from it. So I can get the numbers from the file and insert them into my list. It's pretty handy. I can use the data file handle in the same way that I would use the cin command. And essentially, it treats the input file like it were the keyboard. So data greater than x is just like cin x if I've been typing on the keyboard, but I'm not. I'm reading from a file, and it just grabs the next set of characters that looks like a double. So if you look at the file, it's going to go out to the file, and it's going to see the 9 and says, oh yeah, that looks like a double, I'll grab that. And then it sees the line feed, or the end of the line, and it says, oh, we must be done, so I'm going to read a 9 in. And then the next time it goes out, it sees the line feed, which is not part of a double, so it skips it. And it sees the 2, and it says, oh, that could be part of a double. And any more stuff after that? No? Okay, then I'm going to call it 2. And then the next time it goes out, it skips the line feed, grabs the next number, and so on and so forth. Now, what happens at the end of this loop? Oops. At the end of the loop, it fails. Data is unsuccessful at getting a number from the file because it's read to the end of the file with the 4, and now it goes back and tries to read another number, and there's no number there. It's reached the end. That puts that whole expression into a false state, and the loop ends. So this is a really quick and dirty way of reading a bunch of numbers from a file. Also, I have that nums in there, which is my variable for counting the number of numbers in the file. Nums. I set it equal to 0 to start out with, and then every time I successfully read a new piece of data from the file, I actually increment nums. When that loop is done, nums has the number of nums. And then I continue to use that later in the program. Because our particular list class, primitive and crappy as it is, doesn't keep track of the number of elements in the list. So this is my way of keeping track of the numbers, the number of numbers that I have, which turns out to be useful in a lot of places. Everybody okay with that? And then whenever you open a file, you should always close the file. Just good practice. There are weird things that can happen when you're writing files if you forget to close them. Here we're reading from the file, so I'm not really nearly as concerned about that. But if you're writing data to a file, make sure you close it, because if you forget to close it, sometimes your program will exit without actually having written to the file what you expected to have written to the file. All right, questions? Yes?
I was running into, when I was trying to do something similar, that if there was a 0 in the file, that it might get read in as a false value and kind of quit out of the loop. Is that data in X going to...
I can try that. I've not run into that. So let me put a 0 in there, like that.
That was more in the C in case, but yeah.
And let's see. I don't have to recompile.
Is 0 your first number? Oh, it puts you in
It's sorted, yeah. Yeah, if you look at my main program, you can see, and again, this is me because I don't like do while loops. I sort it, I print it, I print out the summary data, and then I prompt for another value. And then I'm going to continue that until I see, until the user does not plug in a number. And if the user doesn't plug in a number, then what's sitting there is just an enter character, and it quits. But if the user does punch in something, then read the number, get rid of the enter character, insert the number, sort the list, print the list, and print the summary statistics.
What will happen if the user tries to put a character in?
It would fail. Yeah. This, again, I'm writing this. This is a program written by me for me, and so I'm not worried about trapping errors. And I don't want you guys wasting your time trapping tons of errors. Evan.
Would it fail or read an ASCII?
Would it fail? Oh, if I stuck in a character, I think it fails. Different implementations do different things, but we can test it. Yeah.
And then, so, like, if I was doing this command line stuff intuitively, I guess I would suspect that I would want to dereference the RV array as opposed to getting a pointer to it to get the actual value. I'm guessing that has something to do with the fact that it is on the command line and isn't a regular pointer.
So you're talking about argv here?
Right, so argv1, right, I would think would be a pointer to the first thing in it, but since that isn't really in data.
Okay, so you're absolutely right. This is a collection of character pointers, essentially. So each element of the argument array is a character pointer. That's precisely the notation that old style C strings use. And so the if stream constructor knows that and says if I get a pointer to a character, I'm going to treat that as a C style string, and I'm going to go dereference it and go all the way down to the null character and take that as my string. So that's all built in, and that's just the way it works. And in fact, one of my slight pet peeves about C++ is you can't stick a string in there. You cannot open a file name represented as a C++ style string. It'll bitch at you. It'll say, I don't know what to do with this.
As in, if you go string s equals blank and then try to throw s in there.
Exactly.
You have to do that.
And it seems crazy to me, right, that you can't use that low level of a data type to open a file in a C++ file handle. That said, if you ever do run into that situation where you have a regular old C++ style string and you want to use it as a file name, C++ style strings have member functions .c_str, which takes the string and converts itself to a C style string. So you can use the string .c_string, and that'll work. But there's weirdness afoot here.
But argv isn't exactly a C style string, right? Because a C style string is just an array of characters.
A C style string is a null terminated array of characters. So it has to have a 0 byte at the end of it to be treated as a C-style string. And every function that deals with C-style strings is looking for that null terminated sequence of characters. And if that null terminator is not there, weird things happen. Okay. Let's talk about sorting a linked list. So as you note here in my demo, I want you to keep the list sorted, mostly to facilitate the computation of the median. The median is the middle value of a list of sorted numbers. So if you sort the list like I have here, there are 21 values in there. So I just count out to the middle value. What's that going to be? The 10, I guess? Yeah. And that's a 7, and that's the median. The question happens is, what if there's no middle value, right? If I have an even number in my list, do you know what to do with the median then?
Average the two middle lists.
It's the average of the two middle lists. Yes, good word. And that is the technical definition of the median. So you'll have to do that. And again, to find the median, you have to have this sorted list. The mean doesn't need a sorted list. The standard deviation doesn't need a sorted list, but the median does need a sorted list. So the question becomes how to sort this list, and that's what I probably will spend the rest of the time on today, is working through sorting a linked list, which can be mind-twisting. Now, we're not getting into really technical sorting algorithms in this class at this point in the game. Probably 3 or 4 weeks down the road, maybe even a little longer, we'll do all of the various crazy kinds of sorting algorithms. For now, we're going to use a simple bubble sort, which many of you have seen. The bubble sort, let me pull up. For those of you that haven't seen it, this is probably good enough right here. It's a little fast though. Anyway, what's going on here is you do pairwise comparisons all the way through the list. And so this is a backwards and forwards bubble sort. And if two adjacent cells are out of order, then you swap them, and then you move on to the next, and you swap them. And if you do this enough, essentially, if you go through the list, every time you go through the list, you're going to get one element in its proper place. And so if you go through the list swapping out of order elements, by the time you're done, if you do it n times, you're going to have a sorted list. And that's what you see here. Guy just goes forward swapping out of order elements and then reverse swapping out of order elements, and you'll have to make n passes to get the whole list in order. It's a terrible sorting method, but it's simple. Oh yes, thank you. Oh yeah, I don't care. Java is a necessary evil. Okay, here's a more code-based version of it, and you can see we're going to go through the list, and we're going to go through the list n times, and each time we're going to go through the list comparing the current element and the next element. And if the current element is greater than the next element, that means it's out of order. So you go through this whole swap routine. And think about this, for example. What happens when you're going through the list and you encounter the largest element in the list? Once you encounter the largest element in the list, let's say data j is the biggest element in the whole list, well, then clearly it's going to be bigger than data j plus 1 because it's the biggest element. So they're going to get swapped. Now what happens is you move forward to the next pair, and this guy is still the biggest element in a list, and it's definitely bigger than this guy, so you get a swap. And then you move on to the next guy, and it's still the biggest element in the list, and you get a swap. What happens to once this guy picks up the biggest element, what happens after you go through the list and do all the pairs? Where's this biggest element going to be?
Nice.
It's going to be at the end. Now you go back to the front, and there's a next biggest element, right? And as you go through pairwise, at some point you're going to encounter it, and you're going to drag it to the end of the list. So now you've got the biggest element and the next biggest element. You go back to the front, and you're going to pick up ultimately, you're going to slide through and you're going to pick up the third biggest element and drag that to the end of the list. And you just keep doing that, dragging the largest element to the end of the list until you're done. That's bubble sort. I don't know if this... So what's the biggest element here, 85? Yeah, so that 85 is going to get dragged down to the other 85 and stop. And then it's going to pick up the second 85 and drag it to the end of the list. Of course, we could be here 7 years.
And this is about how fast with this bubble sort.
Exactly. But yeah, the way this is written, it's going to leave that 85 there and drag the second 85 to the end of the list. I think.
Can't you just make the speed faster?
Probably.
Yeah, there's one down there, right?
Oh, there we go.
So much faster. I'm so confused.
You're not confused. Yay, there was much rejoicing. Okay. Now imagine this is a linked list. Imagine this is a linked list. So I did a little... I have no idea if this is going to work, but I did a little preparation. It's rare that I actually prepare for class. Okay. So I'm going to build a linked list out of this. Let's go to lasso mode. And then let's grab some nodes. And then let's get null. Exactly. Okay, and let's build a linked list.
Whoa. Oh, yes, astounding.
Oh, come on. And okay, so there's sort of your generic linked list. Let's talk about bubble sorting this thing. So you've got values in there. I'll leave them to you to imagine. If you want to switch or swap two nodes, there are a couple of cases you have to deal with. There's the case where the first node needs to be swapped, and then the case where any subsequent pair of nodes needs to be swapped. So if the first and second node need to be swapped, there's an additional thing that you have to do, and that's update the head pointer. But if subsequent nodes need to be swapped, then that's just always the same. Evan, question?
Could you do this the way of just changing the values in the nodes and leaving the nodes as they are?
You could, but it would defeat the purpose of a linked list to do it that way. Why? Well, the examples that we're doing in class and you're programming are integers, and absolutely the right way to do it is to swap those integer values. But if the things that you're swapping are 7 billion element matrices, then what you want to do is move pointers around. Okay? Okay. And you know, you laugh, but this is the kind of stuff that's happening at Facebook and Google all the time, right? They have these massive records associated with you, and they're not copying records from one node to another. They're just moving pointers around. Because memcopy is really expensive. And if you can do it by moving, let's see, I think we end up moving 3 integers, right, as opposed to copying 14 billion floats or something like that. Big win. Okay, so what you want to do, if let's say I want to swap, let's go with the generic case. I want to swap these two guys. If I want to swap these two guys, this guy needs to point at this guy, right? He needs to point at this guy. And is that enough? No, I've got to fix this guy also. So there are actually 3 nodes involved in a swap. In a swap of linked lists. So what you have to do is get 3 cursors, prev, current, and next. Let's go full screen here. And am I still in lasso mode? I am. Okay. Let's grab these guys. Let's do this one. And this guy. And this guy. I should have put little arrows on those. Oh well. For some reason it doesn't remember that I'm drawing arrows from one arrow to the next.
And our cursor is just another name for a pointer.
Yeah, it's a node pointer.
It was the type def thing, right?
It's a node star. Yep. Okay. So in fact, I'm not even using a cursor. I'm using 3 cursors, I guess, if you want to call them that. Previous, current, and next. So I'm sliding these guys down the list. And what I'm really interested in are the values of current and next. And if they're out of order, I need to swap them. The only reason I need to know prev is because prev needs to point to next if a swap has to occur, right? So let's think about this a little bit. And by prev, I mean the node that prev points to has to point to the node that next points to. All right, so let's pretend that we need to swap these guys. This guy, we can safely, well, let's think about this. Yeah, I can safely move all of these guys around without losing anything because they're stored in prev, cur, and next. So you can decide the order in which you want to do this kind of stuff. But we can grab this, and we just need to move this guy over here. We need to move this guy to here, and we need to move this guy, come on, to here. And that's the swap. How do you go forward in Microsoft Word? What is it? Thank you. So I can do that. All right. Wow, that's cool.
Didn't we just swap current and previous?
Let me just check. So I want to swap current and next. Right? Current and next. So yeah, I did that wrong. Sorry, Control Z. It's mostly because I thought this was current. All right, let me. Is this the original configuration?
Yeah.
I think so. Okay, I want to swap these 2 guys. Sorry about that. So yeah, current and next are out of order. I want to swap those 2 guys. See, so all right. So I can move this guy to here. I can move this guy to here, and then I can move this guy to here. Now am I good? Yes. I always have to write these things down when I'm writing code. Like when I was writing the bubble sort yesterday, I've got scrap paper, little nodes, little arrows, and I just, yeah, maybe you guys can keep it in your head. I can't keep it in my head. Okay, so that's a sort of a generic swap of nodes. The only difference that you have to worry about when you're at the head, so let's undo this, Control Z. Let's pretend that we want to swap these two guys. All right, so let me grab my my lasso and see if I can actually get this. Nope, that's not going to do it, is it? Sadness. Okay, and then grab this guy. So if you're at the beginning of this whole thing, that didn't work. There we go. So if you're at the very beginning of a pass, prev can't point at the previous node because there is no previous node, right? So you can make prev point at the first node, or you can make prev, I don't know. It almost doesn't matter. If these guys need to be swapped, then head needs to point at this guy, right? And this guy needs to point at this guy, and then this guy needs to point at this guy. And prev doesn't really enter into it. Okay? I wish I could give you sort of better advice. You know, I could write down little recipes for swapping nodes in a linked list, and whether it's at the head or what have you. But it's only going to work for a linked list. And what you really need to do is just kind of, sadly, just think it out. Because there are other things that you want to do with linked lists. For example, inserting a node or removing a node. And all of these things essentially just require a little bit of scratch paper, some boxes and arrows to think it out. And you're much better off if you can just make a sketch and move some arrows around than if you're trying to sort of memorize a bunch of recipes for how to insert a node, how to delete a node, how to swap nodes. So you certainly don't need to do it on a computer. A piece of scratch paper, some boxes and arrows will get you through it.
If we wanted to swap two non-consecutive nodes, it'd be a bit different, right?
Yeah. All right. Any questions about that? So this is what you're going to go through as you do the sort algorithm. Testing this thing, for example, let's go back here and get rid of that and go to nums. In fact, I want to save that. You can find problems with your program by testing extremes. So when you're dealing with pointers and linked lists and so forth, it's the extremes that mess you up. So I've just changed this thing so there's only one element in the array, and frankly I haven't debugged this thing, so it might crash. Who knows? Okay, that's promising. 1 point, the mean is 9, the median is 9, the standard deviation is 0. I don't know if that's true for a 1 point list or not.
Yeah.
Is it? Yeah. Yeah, I guess it is. the mean minus the, yeah. So that's promising. And you can throw another one in there. Okay. If you wanted to test and make sure that the swap at head was working, you would do something like this, right? Because in order to sort this list, there has to be a swap of the first two elements, which means there's a swap at head. So you would try that, and that looks like it's working as well. I have no guarantees of what this will do with an empty list. I'm not optimistic. Not bad. I'm not testing. Unfortunately, I'm not testing the mean or the median right now for empty lists. So I guess because those don't make sense. None of those make sense really for an empty list. So what you might want to do is trap the empty list situation and print out, a star or something for an empty list, the mean of an empty list. But at least it didn't crash. Let's see if I can add something to it. Yeah, good. I have faith in my programming abilities. So do that. Test your stuff really thoroughly, because that's what I'm going to be doing. I'll be testing it so that I'm testing a swap at the head. We can test the swap at the tail as well, although that looks like it's probably okay as well. But the swap at the tail is really no different than any swap in between, if you think about it. If you go through the box and arrow diagram, you'll see that swapping at the tail moves that null pointer from the next guy to the current. Everything just works out. All right, let me finish with this repetitive prompt thing. I talked about it a little bit, but let me just make sure that we're all on the same page. Okay, so here's my repetitive prompt. And again, here's me avoiding a do-while loop. Essentially print out the first run, the first list of numbers and summary statistics, and then I actually prompt for a value. And then I drop into this while loop with this see and peek thing. Those of you that haven't seen see and peek, it's a really useful tool for detecting empty input, and it's also useful for trapping errors. For example, if I type a K in and I meant to type in a 9, you can trap that. What peek does is it goes out to the keyboard. After you hit enter, peek goes out there and says, what's the first character on the input stream? And if the first character on the input stream is a \n, which stands for what? Return or enter, then it's going to see that you didn't type a number before you hit enter. All you did was hit enter. If it sees that guy sitting out there, I'm done. Loop's over, program's over. If it sees anything else, so not equal to an enter key, if it sees anything else, it's going to assume that you put a new number there, x. It's going to read it in. That's the first line. The second line is really, really important. What's the second line doing?
Getting the enter.
Yeah, when I entered x, I hit enter, right? I type a number and I hit enter. So there's a number there and there's a little enter character there. If I grab the number, suck it into the computer, cin is going to leave behind the enter character. And that's going to royally screw up your program afterwards. So what you want to do, not royally screw it up, it's not going to do what you want. It's going to stop prematurely. So what you want to do is grab that number and then the get. What does get do? What it does is it reads a character from the input stream. And for our purposes, that's enough. It reads the character from the input stream, essentially throwing it away, or essentially removing it from the input stream. The difference between get and peek, does anybody know the answer to that?
Peek doesn't throw things away.
Peek will get a copy of it, but leave the original out there on the input stream. Get will actually get that thing off of the input stream. So peek is really useful because it lets you go out and look at what's waiting to come in without damaging it or disturbing it.
Now, when we're using cin, kind of like, third day of like 167 style, we don't have to do the cn dot getting to throw away the enter. So does like cn, if there's an enter key in that first spot, does it throw that out?
Yes. So cn, see that cn x right there?
Yeah.
It's going to skip any white space that it encounters, and it's just really greedily looking for numbers.
Or a null character.
It'll skip anything except for a minus sign, a decimal point, or a digit.
Gotcha.
And when it encounters those things, then it drops into a different mode. It drops into gobbling up number mode. And it'll keep doing that until it hits a non-number, like a space or what have you, and stop. And that's the whole number. And you can think about that, right? That's a complicated process because you're reading the number backwards, right? Let's say somebody types 954, right? And cn goes and it sees the 9. Okay, I'm going to get the 9. It's a long way from 900, right? Then it sees the 5. It grabs the 5 and puts it there. And then the 4. And then it sees the white space. And now it has to go back and actually reconstruct the number, right? How many did I get before the decimal place? I got 3 of them. That means this must be 900, this must be 50, and this must be 4. So cn is doing a lot of work for you behind the scenes. Give it a pat on the back every once in a while. It's converting those really complicated expressions into honest-to-goodness floats or integers or what have you.
Is it doing that based on the type of x?
Yes, absolutely. So if x is an int, it'll read up and it'll just read plus or minus and digit characters. But as soon as it hits a decimal point, done. Because there's no decimal points in ints, right? Yeah. So yeah, what goes on behind the scenes in cn is, in terms of reading in these numbers, is quite sophisticated. Okay, next time we will start talking about stacks and maybe start thinking about writing a calculator program. But you have what you need now to do this linked list exercise. All right. See you on Friday.